Taking a look at another one of our headline-making stories, the Sri Lanka Navy intercepted a trawler with 21 people on board who were attempting to illegally migrate to a foreign country. The trawler was intercepted in the sea area 170 nautical miles off Chilau. 107 kilograms and 22 grams of heroin were discovered on board an Iranian vessel that was apprehended this morning in the southern seas of Sri Lanka.
We have seen a lot of increase in illegal activity around the maritime borders of Sri Lanka in the recent past, especially with the recent import bans due to COVID. And as we have seen on the news, the Navy has to manually search for this illegal activity day and night. So we thought to ourselves, why not automate this entire process? Why not have a camera that is able to detect objects or individuals or actions that would seem suspicious, and be able to do that automatically, so that we reduce the workload on security personnel, especially because they work long hours, day and night. It is easy for humans to miss things sometimes, and if we can automate this entire process, why not? So the idea that we came up with was a thermal camera for operation during day and night that is able to detect objects, track those objects, and identify whether there is any suspicious activity going on in that particular frame or in that particular sequence of frames. We use a fairly new object detection algorithm called CenterNet, which identifies the center point of objects in the given image, and is able to also predict how large those objects are, so the height and the width, which is much simpler than a lot of the other object detection algorithms that we have seen come up in the past years. And we have achieved very good results both on maritime images of ships and also on thermal images. And we are confident that the combination of these two domains will be easily achievable for this object detector. In fact, using our own thermal camera, we recorded scenes of a Colombo street, and we ran a pre-trained object detector, the CenterNet, on that, and the results were very good. It was able to easily adapt to the thermal domain, easily adapt to the local domain, even looking at objects it has not seen before, such as three-wheelers, and it did a perfectly good job. We use the SORT object tracker, standing for Simple Online Real-Time Tracking, which uses the output of the object detector and a simple Kalman filter and Hungarian algorithm for matching to track objects over time. So it's very fast, it can work in real time, there are no problems there, and it is very capable of multi-object tracking. We have developed our own activity recognition algorithm. So we aim to localize actions both in space and in time. And for that, we use the very same backbone that we use for the object detector, that's the CenterNet backbone. And from there, we improve an already existing object linking algorithm to link the detected actions across time in an optimal way. It's a greedy selection algorithm that chooses the best tracks for the best objects, and it's able to do this very fast. And therefore, the entire action detection pipeline is able to run in real time. The final part of our project is putting all this together in a very user-friendly interface, so that the objects that are tracked, detected, tracked, and the activities that are recognized can be centrally monitored. The alerts can be sent to the relevant people. So we developed this user interface, and we have loaded the algorithms that we have already developed onto that. So it's capable of object tracking and object detection already. And once the activity detection algorithm is developed, that too can be integrated. So the user interface keeps track of the objects that are already detected and that are already tracked. It assigns them IDs, and all the objects that are detected over time are recorded there for whatever purposes they are needed for, such as for identifying which objects are in the scene, where they are going, etc.